Class, welcome to day 2 of 7.3 Triangle Similarity. Today we are going to focus on using the fact that we have similar triangles to solve for missing pieces, missing side lengths. Okay? So, these problems will have two steps. The first step is figuring out whether or not the triangles are similar. Once you figure out that the triangles are similar and you give your reason and you have your similarity statement, then we can set up proportions to find a missing side length. So what is that going to look like? Let's jump right in and see. So something like number 1, we have this goofy looking shape. I'm not sure exactly what that is. What I am looking at here is the two triangles below. Alright, now, when I look at this picture, I definitely see a set of vertical angles, so I do have information on one set of angles. That should be my hint that I cannot use angle-angle, because I know nothing else about other angles. And I can't use side-side-side, at least in this case, because I don't have information for all three sides of both triangles. So I'm going to try and use side angle side. Well, what's really nice is I already have that included angle. Okay, I already know that this angle is congruent to this angle, so I have that one angle done. Let's set up the proportions to see if the sides are proportional. So I take a look, and maybe I'll work off of this small triangle first. So something like UZ, which has a measurement of 10, well, I'm going to have to compare that smaller side of this triangle to the smaller side of the other triangle, so ZY, which when I plug in, 10 over 25 equals 2/5? 2/5. Alright, let's check out the other set of sides and see if that ratio is the same. So now I look at VZ. VZ is my longer, or I guess my medium side of this triangle, this baby triangle, and I have to compare it to this medium side of the other triangle, or ZX. So, when I plug in, I get 14 over 35, divide everything by 7, and what do you know? I get the 2/5 again. Alright, so we now know that these triangles are similar. We know it because of side angle side similarity. And we can even go ahead and say, let's say, okay, I want to go UZV. UZV is similar to YZX. And again, just be careful, make sure that you line up the angles. U has to line up with Y. Z has to line up with Z. And lastly, V must line up with X. Now, we are trying to find XY, or this side length right here. I'm going to label it as an X. Okay? Don't get confused with vertex X. I want that side length of X. I need to set up a proportion to help me solve this. If we notice here, I have UV. I do not have XY. But UV, which is the first and the third letter, well, that has to be proportional to YX because it's the first and third letter of my other triangle, sorry. So let's set up a proportion. I'm going to go with 16, or actually, you know what? Let's do it with letters first, just to kind of clear that up. So UV YX. And that should be equal to, well, now I don't really care. I can use any of the sides that I want, either set. So let's go with UZ. And we know that UZ, which is the first and second, has to line up with YZ. Alright, that hopefully makes sense. That's just saying that this side and this side must be proportional, as well as this side and this side, or this side to this side. Okay? So let's plug in. Now I'll plug in the 16. YX I know is X, or what I'm looking for. UZ 10, YZ 25. Here, I would just go to the calculator, and I would say that 16 times 25 is 400, 10 times x is just 10x, and when I divide everything by 10, I get that x equals 40. That is my value, or length, of xy. And it should be in feet. Okay, so again, what did I do first? First I had to figure out if the triangles were similar. Okay, once you have that the triangles are similar, then you can go ahead and set up the proportion to find the missing length. So something like number 2 is going to be extremely similar. I'm going to split this up just because I think it might help people see this a little better. So this is RSV, and I know some things about the side lengths and the angles. And then I could also draw something like this, because this is now RTU, and I know that this is 12. Now, there's one other thing that I would want to mark. Hopefully you guys are starting to see it from the other practice. Angle R has to be congruent to itself based on the reflexive property. So we can use angle to say that these triangles are similar. Okay, I have one set of congruent angles. I have the same angle, which is obviously congruent to itself. So two angles, so I know that anytime I have two triangles where there are two sets of corresponding angles congruent, I have similar triangles. Now, RSV has to line up with RTU. Awesome. What did I do? I just went in the correct order. I said that R has to line up with R, S with T, V with U. So I wrote my statement. Now the last thing, I'm trying to find RT, so I'm going to put a variable there so I know what I'm looking for. And now I just know that I have to figure out the proportion correctly. So if I'm trying to find RT, I know RT's first and second letter, so that's going to have to line up with the first and second letter of the or the first triangle, okay? So RS, RT, RS, good, we have that. So now we have to use the other information we know, which is SV. And SV is the second and third letter, so it has to line up with TU. So now when we plug in, we have 10 over x equals, what do we got? 8 over 12. When I cross multiply, I get 120 is equal to 8x, or x equals 15. Alright? 15, no units here. If you want, you could put units. I'm not going to be a super stickler on that. Only thing I would be on the lookout for, make sure whatever you're trying to find, you always make a variable, okay? Sometimes we might ask for ST. Sometimes we're going to ask for RT, the whole length, okay? So that's just something to be on the lookout for. If you are going to solve for ST, you might have had to do a little bit of a different calculation. Hopefully you guys can see that, and there will be problems like that, so we can get to them when the time comes. Alright, if you're feeling okay on this, I'm okay if you stop watching and just get back to practicing in class tomorrow. If you're not feeling so hot on this stuff, please stick with me as we flip to the next page for some extra practice. Okay, so we have two more problems, very similar. Let's see here, what do we have? Well, if I look at this picture in number 3, hopefully we're recognizing the vertical angles. So that's great. That is very, very good. What else do we notice? Well, if I have these parallel lines, and maybe I say it's being cut by this transversal AD, well then I can go ahead and say that angle A is congruent to angle D. So I actually can already say that these triangles are similar by angle-angle because I have two sets of corresponding congruent angles. When I come to the statement, I have A, B, C. Make sure you go in the same order. We know that A has to line up with D. B and B line up together because this is angle ABC and DBE, so we'll just put a B there. And lastly, E. ABC, DBE. Good. Now, we're trying to find BE. So I put a variable there so I know what I'm looking at. We need to set up, and I would probably start by saying if I need BE, okay, if I need BE, then I'm going to have to say BE is the second and third letter, so it's going to have to line up or be proportional to BC. So BC over BE, alright, BC over BE, that's good. Now we need to use the other set of sides that we know, okay? Well, in this triangle, I already used BC. I know AB, okay? So I'm going to have to compare BC and BE to this other set of sides the known sides, okay? So AB, first and second letter, DB, first and second letter. Let's plug in. BC is 54. BE is X. AB, 36. BD, 54. When I cross multiply, I get some bigger numbers that I cannot do in my head, so let's check this out. 54 times 54, 2916 equals 36x. When I divide everything by 36, I get that x equals 81. And I would write it. Okay? So again, guys, figure out if they're similar, and then set up the proportion based on your known corresponding sides. Last practice problem for this video. A crazy looking picture, kind of hard to read. Let's break this down into something that's a little more manageable. Alright? So if I kind of come down here and re-sketch, I'm going to say that this is B, F, G, and it looks like this is 6.5. Excuse me. And then I'm going to draw the bigger triangle. Let's see here, this is now B, A, C. This looks to be 24. Other really important thing, these are parallel. Okay, these are parallel. What I'm going to do, just in purple, is I am going to re-sketch this little triangle because I want you guys to recognize that we're using a different angle relationship based on these parallel lines. Okay, so far we've really just used if parallel lines are cut by a transversal, then alternate interior angles are congruent. Now, hopefully you guys can notice that if I have these two parallel lines and they're being cut by either of these transversal, doesn't matter which one, but we can say that these angles are corresponding. Okay, so what I'm going to do is I'm going to say that angle A and angle F are congruent. So that's one step. The other thing, and again, I'm hoping that we're just starting to see this and pick up on it all the time, when you have these overlapping triangles, angle B, it's congruent to itself. Use the reflexive property. So we can say that these triangles are absolutely similar based on angle. Okay? Now, the statement kind of can go in any way. I'm going to say BFG, so the little triangle BFG is going to be similar to BAC. Remember, order matters. So F lines up with A, G lines up with C, B lines up with B. So that has to look the same. Here's that situation I was kind of talking about here, guys. Alright? If you notice, AF, I just marked it, is 17. I also know that I'm looking for BF, so I'm going to put a variable there, because that's what I'm looking for. Okay? I'll have to put it in both triangles. Here is what we kind of have to take away from this. All right, this entire side length is 17 plus x. How do I know that? Well, if from a to f is 17 and from f to b is x, well, then combined 17 plus x. I need to do that because that is how I'm going to have to set up the proportion. I know that if I'm going to say I want BF, oh, I need to come down, sorry. If I'm trying to find BF, well, BF lines up with BA. And then we need to figure out what else do we have. Well, we have this, we have FG, 6.5. So FG, second and third, which means I need to use second and third in the other. So AC. Let's see how this sets up now, okay? Well, BF, we said, was X. BA, we said, was 17 plus X. FG, we said, was 6.5. And lastly, AC, we said, was 24. Alright, when we cross multiply, 24x equals, I'm going to just do this little by little so you guys can see my algebra, alright? I'm going to multiply this. I'm not actually going to do it yet. I'm just going to write it out. Okay? This is a situation where we need to do what? Your favorite. Distribute. Okay? When I distribute the 6.5 to the 17, I get 110.5. So I have 24x equals 110.5 plus 6.5x. We need to collect all of our variables on one side, so I'm going to actually subtract 6.5x. So 17.5x equals 110.5, and when I divide by 17.5, I end up getting that x equals, let's see here, 110.5 divided by 17.5, 6.3. Let's double check. It says, find the missing length. Alright, so our missing length, 6.3 feet. 6.3 feet. Alright, so there you have it. All of these problems, not too challenging. All you have to do is set or figure out that the triangles are similar, set up the proportions, and solve. Alright, hope you guys are starting to understand this. Please let me know if you have any questions. See you next time. Peace.